Alright, I think I'm live. Hello world. Yeah, this is day 76 of studying compilers every day until I land a compiler role. I did a lot of thinking off stream, and I think I know what to do actually. And I made this little sticky note for myself to actually reference today on stream, so I can maybe get a couple more of the tree tiling things ready to go. Hopefully all of you are doing alright in some capacity, or at least in every capacity actually. Yeah, I will always end up being late to my own stream, but that's always how it ends up, I guess, for better or for worse. Okay, so last time we started trying to write these like little mini trees for our what's it called? For our MIR to LIR thing, with the goal of doing instruction selection. And I think I know what to do now. The idea is we first generate trees from every instruction in the optimizer IR, and then we can merge them into, I guess, like the largest possible scope of that tree, and then we can cover those trees with tiles, and each tile represents some sort of an instruction that is hopefully easier to I guess, or it's like less expensive to use, and then we can like do the final cleanup and actually make the LIR program. I want to use Arch as hard as people say. I don't think it's that bad. It's just like a lot to jump straight into if you were starting with that as your first distro. I think it's just a lot of reading docs, but you'll get used to it, I think, at some point. Also, I need to take the garbage out. I'll do that later. Whoops. But yeah, not really a lot to learn, quote unquote. You just have to like be willing to just keep learning things on the fly, I guess. Yeah, I can turn the AC on later. Okay, so I think a good end state for today, or at least like for the next couple of streams, if not today, is to get to a point where all of the instructions have basic like atomic tiles, and then we can like figure out tree merging and tile coverage later. But I think that's like a pretty good bare minimum state to have at least. So I guess we can keep making these tiles. What's good, Izzy? I haven't seen you in a second. I'm doing alright. Hopefully you're doing alright as well. Okay, so we want a register node, we want an immediate node, and then we want op node. We want something that like represents something in between these two, I think. Okay, so you have a child, which is a source. This has no child, which is fair. Op node. This makes sense. This represents a binary op. So I guess let me just like draw out the couple of trees that I'm thinking about right now, at least. Busy doing final projects? Damn, that's tough stuff. Hopefully that's going what's it called? Hopefully that's going all right for you. I can't speak today. Okay, so let's make this tree real quick. So we have reg, and then let's see our reg here. That takes, or this turns into reg, op, and then left, and then a right. So this is what just like a basic binary op would tile to. That I think I guess we could finish up with that one first. That might be a easy one to start thinking about at least. Yeah, so we can do that, and then maybe we should just make these like, I guess how do we abstract this properly? How's your day been? Just a lot of school, I guess. I'm quite tired, but I'm supposed to have a call at some point had YouTube open, NT. I'm supposed to have a call at some point with this week about one of the jobs that I've gotten, or I guess interviewed for. So we'll see what happens there. I don't want to like speak too preemptively about how that goes, but yeah, we'll hear back, and the series will continue regardless. But yeah, it's a small local trading firm. I ended up sending an entire Linux VM to code in it for the port of my script. Yeah, that makes sense. Couldn't get Mac working. That's fair enough. I mean, I think Mac is just generally annoying to virtualize, so that's kind of how it is sometimes. Okay, so how do we make this? So we got register node. This has string name. Maybe I should forgo this sort of. Yeah, I'm gonna need visitors for this anyway, so I think it's fine to leave these sort of like this. Instead of just having like one standardized structure for it. Yeah, okay. And then we'll have a visitor, so I think that's fine. Which books are you reading? I guess currently the one I'm referring to, just to like figure out what's happening here, is this one is the Cooper book, Engineering Compiler 3rd edition. Because this one seems to explain the most about instruction selection, but yeah, it's not really descriptive, which doesn't make me very happy. Yeah, I would like this to tell me more about like how to do this, but yeah. This is the tiling stuff. That doesn't really help me because I need to generate trees right now, I think. The other books I've been looking at are SSA-based compiler design by Rastello. This is just all the stuff. This is like the manual I'm basically, quote-unquote manual I'm referring to when doing SSA stuff. Yeah, and then there's one more, which is, what is it called? It's this one. This is Muchnick book. Is there an explanation of how we lower at all anywhere? Huh, I guess not. Okay, well. I'll figure it out later. Or at least if there is something here, I will figure it out later. It doesn't look like there is anything here, unfortunately, that will really help me yet. I think the regalloc stuff will be interesting though. Yeah, okay, well, yeah, those are the big three that I'm looking at least when just implementing this. Okay, so how do we implement the actual stuff we need here? I guess we could just make constructor for this, and then void set node. Source, we can do that. And then we want a getter, I guess. I guess how are we gonna do merging as well? I have thoughts about that. I'll do that later. For now, I think I care about just like getting the initial tree coverage first. Can we just paste this? Actually, we don't need that here, right? Or we should have a setter for value, probably. at least a getter for it. I'll write proper getters later. We'll just keep it at setters for now. Just enough stuff to build everything. Immediate node. This gets uint64t value, because that we should probably have defined. Yeah, okay. And then here, we can kind of just steal this again. Op node. And this has a and just mir binary op. And then also let's just change this name. This is annoying me. Let's do new. What's wrong here? Oh. Yeah, we have to do new source then, I guess. That's annoying. I guess. New node? Yeah, we can do that. So set left. Set right. Okay. I think that's good enough to generate this. So then, okay. So we can go here. And we can set up the visitor for that first. So we can make a register node, or actually we need an abstraction over these two, I think. Or do we? I guess we don't actually, because then we can do like compound expressions in some way, right? Yeah, or we can just like assume that we do it properly and call it a day. Okay, so the res has to be a register node, I think, at least, given the way this is written. Yeah, so we make a register, and then res. So then we want to make the children, so we want auto op, because that's probably the least awful. Or I guess like that's the next node down if we go back to the diagram. So we've made the register, now we're making the op, and then we can make the children, and then we can like link them upwards. So we want op node. This needs I should probably make a numbering or something. Yeah, if we could like make numbers, that would be really helpful. So I guess we need a constructor for this visitor, which is a little bit relieving, to be honest. Yeah, so let's make that real quick. So let's paste that like that. It's the constructor now. Okay, so we want, I guess we want a program. That's what we need at minimum. So this takes in middle and mir. Then we need program, I guess. Program putter, or just P, I guess. We'll do that. Ref, so we don't have to copy things. Try a mini compiler for PyTorch? That would be interesting, yeah. I just don't know a lot about it, or at least I don't know a lot about ML compilers yet. But I think I still need to familiarize myself with the basics before that point at least. Which is why I'm focusing on a more general purpose compiler first. Maybe once I get maybe when I get more of this done to like a more steady state, I might start looking at other compilers. But for now, I think the main course of focus that I have is specifically on just like general purpose compilers, or I guess compilers for general purpose languages. And by general purpose languages, I mean C for now. So yeah, we're gonna exhaust this as much as physically possible. Okay, we need to keep the program, I think. Or maybe we don't need to keep the program. We just need... Maybe we just need the numbering for it. So you have MIR. Our middle end, we want analysis. And we want number IR. And this is very helpful actually, because we don't keep names in our IR. So, or at least for like values. So it'd be very nice to have something that makes the names for us. So you have number IR and IR. And this is nice because we aren't writing like a transform, so this will just be fixed. So then we can NR run on P, I think. Yeah, and that's good enough for the constructor for now. Yeah, and that just goes through it. It reads everything, calls it a day. Yeah, maybe I should like, maybe it'd be cleaner if we just did like proper dependency injection here, but whatever. I think this is fine. Okay, so then, how much time do you spend sending your resume to job openings? Honestly, I've been kind of cooling down on that because I'm starting to realize that like, it kind of sucks and like I need to deal with school, so. I've definitely been like slowing down on that a lot, but at least during like peak recruiting season, I think I was still being quite lazy with it, to be honest. It's just like, even though I want to like do compiler stuff in the future, it's kind of hard to find an internship anyway, and that's just very demotivating. So, I probably spent like roughly 2 hours a week maybe, which is definitely on the low end. And I'm grateful that I have like some sort of a backup internship. But it's just like, I guess I definitely could be trying harder, but school is kind of just ruining my life. So, I try to save energy where I can, at least. Okay, so we'll get number for Duly Code Daily. I've stopped doing it, to be honest. It's just kind of, how do I describe it? It's kind of just like rage bait. Like, I did it for a while, and then like I got to system design week, and then I was like, I'm not learning anything from this. This is just, I feel like I'm just getting my head bunked over a wall for like no benefit. So I ended up just not working on it, I guess. We need to string this. Yeah, it just didn't feel very it didn't feel very productive to me, at least. This should be a correct constructor, right? Unique pointer. Oh, make unique. Whoops. There we go. So we want to once again make unique. And this will be we want I get op. Usually for someone out of school. I'd hire you in another role because you're attacking compilers, not easy. That makes sense, yeah. I think, yeah, I guess like I am trying to just like go from A to C. So I think I think it'll be a lot easier once I have like a year or two out of school. But in the meantime, I still need to like actually know about compilers to like be able to get the jobs that I want. So I guess this is kind of the stuff that I'm doing to stay on top of that, at least. Well, the school will be over before you know it. Yeah, I mean, I've got a year and an extra quarter, so it feels very fast, I will say. This quarter feels way faster than all the previous quarters that I've had. It could just be because it's like in the present, but even still. Okay, so we can do that. And then we want res, set source. And that should be stood, move, op, I guess. Or we should do that later. Wait. Should that be a pointer or a unique pointer, actually? This is really annoying, actually. I think I'm gonna structure it as a unique pointer. Yeah. We're gonna replace node putter with stood unique putter to node. Yeah. Yeah. Okay, this does what we want it to now. Yeah, so we can set source to that, but we want to do that later. We want to make everything first, and then we can link it in reverse order. Yeah, and this might just like make a mess out of memory, but we can optimize it later. Maybe with like some sort of global state management thing. That seems really annoying though, so I'm inclined to avoid that. Yeah, we can patch holes as we progress. Okay. So we have op, and then we want to make auto left equals stood make unique. We should maybe dynamic cast this, right? We should add more helpers for all of this. This is pretty funny. Yeah, let's make a helper real quick. Should this even go in TreeGen Visitor? It probably should, yeah. We can do like void, or no, we want stood unique putter to node. And this is like, resolve value, I guess. Oh, we want value putter v, I guess. Middle end mir value. Yeah, okay. So we should steal that. Okay, so then auto. So we want. So currently it's either an immediate or it is a register, I guess. Or it'll either be an immediate or it'll be a register. And because we don't really have like direct memory accesses yet, that will be a whole saga in and of itself. And I'm scared for what that's gonna do, but hopefully we design code in a way that is easy to incorporate that in the future. But as that sentence implies, that will be a future problem. So for now, I'm gonna make this just, so this will be literal equals dynamic cast to middle end mir literal. Did we have a node for like function params? I don't think we did. That'll be a special case that we need to worry about later. Okay, so we have dynamic cast to literal, literal putter, and we can take v. Real quick, before we continue, I just want to template this out a little bit more. I guess scaffold it out. So this should be resolve value to, or wait, let's add TreeGen. Okay, and then resolve value, and this takes I get left do right as well. Okay, so then we can do up, set left to left. We can do right. Okay, so then that goes back up and then it builds everything. Or we could just build this bottom up alternatively. I think that makes more sense in my head, so I'm gonna do it like this. Yeah, so we can do that, and then we can do something with res, I guess. Or we could do like reg, I guess we can call that. Yeah, reg makes more sense in this structure. Okay, so then moving on, we can get back to this thing. Okay. So dynamic cast to literal. If literal is not a null pointer, then we have a literal. Then we can return std make unique of type immediate node. What does this take again? This just takes literal get value. Yeah, so we can do that. Otherwise, we can return std make. It's a register. Function params. This will never die. This singular line of comment will never die. Even though I have implemented function params, it will always never die. It will always persist somewhere in my code. Okay, so then we can do register node. And this will be v, or we should do nir get number of v. Yeah, so we want std to string of that. Okay, that's all we need for that little thing. And that's nice because then we can just reuse that and then we can keep this going. Okay, so we want to hold the trees somewhere in this visitor, I think. I'm trying to think what the best way to do this is. I think we just want to list, maybe? Yeah, because like I think a lot of the benefit of using a, actually, no, it'll still be slower than a vector, but I think we will want to like do a lot of in-place operations on the list. So it would be very nice if we could, I guess, have reasonable time complexity on inserts and deletes that aren't at the ends of the list. So yeah. So with that we can do std list of, let me just move this up, or small l, list of node or std unique footer to node. You can give it a name. This will be trees, I guess. Yeah, okay. So then here we want to trees tress. We want to push this back. Okay. So that generates this tree now. And this is starting to seem like it's not so bad, actually. We might need to add a node for function parameter. Or we could give that like a specific register. That might might be difficult to think about though. Okay, so that's the first tree that we care about. The next one that I looked at, was call, but that one is a little bit sloppy, so I don't want to do that right now. The next one, I think I just want to deal with like the load, allocate, and store stuff. I think that will help out a lot, and then we can do like, and then we add return, I think. Or return might actually be pretty easy. I think we do return next. Okay, so this one is binary op. So like v equals l plus l. I don't know. What do we do lowercase l? We can do that, I guess. Yeah, so that is what this represents. Let's just draw this all over again, but smaller, so we can read it a little bit better. So you have reg. Yeah, that's. Can I draw a circle? That's circular enough. Okay, so then this gets op. And then op has variable, or I guess like value, and then it has value. Just to simplify things, maybe what size? 2, okay. I can pen this over real quick, and let's make this just R to simplify it a little bit. So this is the binary op, so like value equals, it's like I equals A plus B, or I guess A op. Okay, we need to make this more clear, I guess. Yeah, we can just do I equals A op B. So the next one we care about is return. So this will be like what? Return I guess like value. So then this is just, we have a value at the bottom, and then this gets a straight line node to return. Or just a generic return. I'm not sure how I want to do this sort of thing. I think just calling a return node might be the least awful way to do it, and that just has a child. And then we can like figure out merging trees later. But that seems like a pretty good atomic tree for this. So then we need a separate node here. We can make it like special node. Or maybe returns always just get their own thing. How do we structure this? A return should always be the end of a sequence, I think. So then that will handle itself, maybe. We kind of need to like maintain the control flow graph, sort of, I think. Or at least we need a way to linearize, which is the other problem that I'm going through here. Yeah, all of these are instructions, right? Even the terminators, right? So we can kind of make like a separate linearized analysis or something. Or I guess that'd be like a transform, but not really. Let me just like look at my middle and stuff again. Because what's happening here is, so like we have this return node that's like pretty easy to represent. We have like a conditional branch. And that makes sense because we just give it like a condition. But the problem arises here when we have to get to just like straight up branch. Because what does this take? It doesn't really make sense, right? So I think we need to think of a way to linearize it, and then that will hopefully make less of a mess. So yeah, let's undo some of this. I'm trying to think how I would go about linearizing. Or I guess that just takes a label, huh? Yeah, that would just take a label, and that's fine then. Yeah, okay. So we can make it just take a label. Or I guess like a... I don't really have labels yet. So we need I guess a better structure for our data, or we need like more precise data structures to represent what we want. Oh, let's go Niraj. So I guess like we currently are. Let's make a new drawing for this. So we have like MIR program, and then this is made up of functions. And then this is made up of like multiple basic blocks. And each of those have instructions in them. Or maybe we could just make like one big function as an example here. Just assume that we have multiple functions. Yeah, so this has multiple basic blocks in it. And this is made of a lot of instructions. Yeah, we'll be brief with this. Yeah, so then our end state is just, what did I call it? LIR. And then this just has, this just has blocks. And then those are just a bunch of instructions each. So let's make like, oh my god, I can't draw boxes. Let's just draw like this many boxes. This is just block. Yes, I'm drawing these with mouse, by the way, which is really awful. So I guess the block itself is the label, which causes a little bit of a problem. So we should probably add like a label instruction. And then just like I, and then like I think it still has a terminator, but it's a little bit more interesting, I guess. Yeah, we can just continue on forward like that. I was trying to install a C++ library for OpenGL and took 3 hours. C++ needs a first-party package manager fast. I mean, they've also kind of been saying, like, it hasn't had a package manager for like 20-some years and like it's still alive. So like, I think it's fine. I think it probably should have a package manager, but that's like first party, but like I don't think it's the end of the world at least. And like I think it's fair that it doesn't have one at least. Yeah, so we need to bridge this gap somehow, and I don't know how to bridge this. So we just want like trees first. So trees, and then that's something. I don't know what the program unit is gonna be. Let's look at some assembly. Let's look at some example assembly. Something that might be useful. Is there a good example for how to structure this? This is like a terrible way to learn assembly, by the way. Do not learn it the way I'm learning it right now. I guess further down it's just, I guess this block structure is like a little bit too much even. Yeah, maybe blocks should be implicit. We should just have like, we should just have label, instruction, 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 and then label eventually. That might be the play. And then we just like control flow graph it as much as possible. Yeah, okay, that might be what we have to do. Which really sucks, but it is what it is. Yeah, none of this is really helpful. This is definitely not helpful. This is not what I care about. You're not gonna generate jumps to places that aren't blocks anyway? Yeah, I think that's the case currently. I have no idea how I'm gonna even think about handling function pointers. So I'm just gonna stick my head in the sand and pretend they don't exist. So I guess like we could set it up as blocks, but like at like RELA we're gonna kind of get rid of, I guess like we don't need blocks for anything else later on anyway, right? So it seems a little bit silly to structure LIR with blocks, at least, is the way I'm thinking about it. We can just have like a straight list of instructions and call that a program. Or call that a function, I guess. Is that what I even do, actually? What did I design this as? That's instructions, that's fine. Yeah, so we have blocks. I don't know why I decided to make blocks here. I feel like we should just have a program, and then... Yeah, we should just have a program. I think. Do you have your caps lock key remount to escape? I don't. I really should, but I'm a little bit too lazy to. Yeah, I'm starting to doubt my choice here of blocks. Yeah, this separate label thing is definitely very troll. I should definitely just have label as an instruction, I think. What to do? What to do? Okay, we're getting rid of block, I think. I'm not very sure about this yet. I think a program should just be a list of instructions, to be honest. Or maybe, how do we handle functions? Oh, right, functions don't exist, I see. We just have calling convention. What is instruction selection? We have a optimizer language and we have an assembly set. They are not a one-to-one mapping. We need to generate some sort of a mapping in or at least as efficient a mapping as possible. Let's see if there's like example x86-64 code. Anything interesting here? Let's do add. Or maybe like if there's something more complex I could look at. Oh, this is really funny. Yeah, okay, we should definitely just have labels as we should definitely just have labels as a unit in our code. And I guess we can kind of embed calling convention anyway while we generate things. So that'll be useful. Oh wait, I just realized something. Okay. Yeah, so we kind of just have a list of instructions as our program, I think. Like if we have like an assembly file, yeah, like it's just, it's just one body. So like, we can generate like the preamble stuff on our own. But this is, yeah, so this whole structuring thing kind of breaks down. We don't even need like I feel like we don't even need like an object for this. We can just use the type def and it's really funny. And that'd be like a little bit cursed, but I feel like it might be something that's smart to do. I'm thinking about it. I'm really thinking about it. Do we just type def a list of unique pointer of instruction as a program? Oh, what do y'all think? Is that too cursed? Is that alright? Do you just not have an opinion, which is also fair? Because honestly, that might not be a terrible way to do this, I think. I guess regardless, we're getting rid of block, so I can get rid of that. And then by extension, we can get rid of block here. Yeah, and then this doesn't really make sense anymore. So then, instead of block, we can just replace all, I think. Yeah, this is instructions. Is stood a class with the methods or a namespace? I think it's a namespace. Like, at least, like, when you're, like... let me just do one more, find replace. Yeah, okay. But, like, if you think back to, like, when you were first learning C++ and, like, all the tutorials, like, using namespace stood. I think that is, like, a very clear example of where stood is a namespace. We should do this again. Okay, well... This seems a little bit silly. This data structure seems a little bit silly. Actually no, this doesn't, because we want a toString here, right? Or, yeah, we want a toString, and that will be the code gen, I think. Stood string. How do we do toString in all the other ones? Yeah, we want toString, so I think this is fair to keep in here. Yeah, so like in the program level, we have toString. Yeah, I think that's what we want. And then, I think we also had like that instruction manager thing, right? Or like data, whatever I called it. It's not in data size. It's an operand manager, yeah. So that's also where this will live, I think. Yeah, because that will handle where things like literally live. So we want operand manager, or unique pointer, I guess. We can call this OM, and that's really funny because it's like because I'm like hungry. I'm like, I want to eat. I've already eaten, but like I want to eat more. Where is the other instance we have like a utility thing? It's in MIR, right? With the, what's it called? The literal math thing. Then what do we, or not literal map. basic block edges thing. Yeah, okay. So I don't think we need this to be a unique putter. Yeah, there shouldn't need to be a unique putter. Let's go back to here. So we can just do that. And we have we get from this. Okay. We can do more things to it as we need, but I think this is a good start for what our program looks like, and that also cuts down on a lot of the other stuff we need to do. Yeah, so we want re-implement the body stuff here. We have get instructions, stood, string, to string. And then return, let's just make this return nothing for now. Or at least return empty string. So it doesn't yell at us, hopefully. I think the operand stuff is still fine. It's just a little bit messy. We might have to restructure it a little bit. Do we have a singleton equivalent here? Yeah, these are kind of like reducing copies as much as possible. Okay. I think that's fine for now. Yeah, and the rest of this is still, I think, pretty tenable. So we can go back to this MR to LR crap that we were doing. This is the header. This should be the C++ file. Okay, and why did this matter again? Oh, right, program structure here. So now we don't have this notion of a block anymore. So then we can just like give it label nodes as well, I think. Or at least we can map things to labels a little bit better, which will be nice. That also reminds me, we need to add a label node. Or a label instruction. Yeah, that should, I think that counts as an instruction, so we will, we can call it label. We got stood, string, get name, I guess. And then on a constructor. And then we want private fields for it. So let's implement it real quick. Fix this real quick. So we want stood, string, label, get name. Okay. I think that's all we needed to implement there. Let's commit some stuff real quick. This is remove notion of block from LR. Okay, so now all of that is committed. Let's go back to the MIR to LIR thing. So we have, I guess we have a good way to represent trees now. We're gonna need to figure out a way to group them that makes sense though. I think we can just group them per basic block, and that will make reasonable sense. Yeah, I think that will Yeah, because those are like kind of the context for each variable, right? Oh, not really. It's kind of just like function wide. So the functions are definitely like the absolute barriers of context, but is there some sort of grouping that we need to do outside of function? I guess we could make a context actually. Or just like some sort of context, or we can do a list of lists, I think. And then we can, or let's steal what we had here. Let's paste this up here like this. Cur context. And then this we need to replace trees. Yeah, like this. Does this make sense to me? I guess maybe we could make like a this is awful. I guess we need to like figure out a way to linearize it first. Maybe like a linearized analysis? Or maybe that's a transform, I don't know. The more I've been using C++, the more I've noticed that's verbose, but it helps you keep track of things since it's so explicit. Do you notice that too? Yeah, I think that is like a pretty good way to think about it at least. And like Rust kind of takes that to another extreme. And like depending on the type of person you are, you'll either like really, really like it or really, really dislike it. I'm in the camp of generally liking it. Because like you can, I think if you like write your code properly, then you can more easily figure out what your code is doing, or at least remember what it's doing. But I think like a language that takes that and kind of makes it a mess, I think would be actually, I'm not sure if there's an instance where it makes a mess. I think Java just has a really bad reputation, which is where the idea comes from at least. But I don't think it would be that bad at least. Okay, so then I guess I'll figure out how to manage context later. For now, I think we'll just assume everything gets pushed onto the last context. Right? Yeah, we'll do it like that for now. Yeah, okay, we'll do it like that. Okay. So I think that means we can just make a return node, and that will be interesting. Where'd my drawings go? Yeah, here. So then I guess we could draw all of these out real quick. Or at least all the ones I want to do for now. So we can do return. And then we can do a register is a load, or a load is a load goes into a register. And then the load takes a pointer, so I guess we have to do another straight line here to like put her. Yeah, so that takes a putter, and this is R equals, I guess like R equals, or we can do I. Load P, I guess. And then, of course, the counterpart to that will be store. Yeah, so then this one takes a store. And then this takes two putters. Or it takes two things. It takes a value, which will be just any value. And then this takes a putter as well. This will be like that. This is store. We store v into putter, I guess. I into putter. V into putter. We can do v. So I think that's a pretty reasonable subset for what we have right now. Oh, we also need allocate. Or at least some way to like make putters. So this is like putter. This is just allocate, I guess. Let's go keep it up, thank you. I'm not sure if I want like a size here, but I'll indicate that maybe that's something we care about. Actually, we need a size there, I think. Yeah, and that will be that will be a value, I guess. For now, we can make it a we can make it an immediate for now. We can make it a value. Let's just make it a value. Let's keep it simple. And then we can generate it with immediates only. Yeah, so that is an allocate. This is putter equals allocate. And we allocate v size. So those are like the basic trees I think I want to get done today. After this, we have to worry about like call. Let's just add this on another layer for now. So call, we want to worry about fees somehow. We want the other two control flow instructions. So we want like branch, and then we want cond branch. I think that covers our whole language. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we go back to the middle end, MIR instruction, let's just go to visitor, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that covers everything. And we can generate these basic trees, and then we can start merging them after we get to that point. Because the idea is that like the store we can like these we can like chain with this op thing, for instance. So like let's just like very crappily make a copy of this. Let's make a new image. Yeah, so we can like take this. Let's put it, oh god. Let's put it in the middle so we can do things to it. So let's say we want to represent store. We're gonna store like load from putter 1 plus a load from putter 2. Yeah, and then this goes into. All right, let's go back a step. Yeah, so we have like. Oh, I have text. I forget I can type. Anyway. Yeah, local computer scientist discovers that you can type in image editor. Let's say we have like a plus equals 2 as an example. So the way this would be represented in our MIR as an example would be like load from putter 1, or it's like var equals load from putter 1, and then like var equals var plus 2, and then like store a or var into putter 2 as an example. So then we can take each of these, we can generate a tree for that. So we have also this like goes into the stuff I want to do I think next time after I finish all the trees, but this is like more theoretical. Yeah, so we have all of that. I guess we can start filling in what would go inside the trees as an example. Yeah, so we have var op, or this is plus, this is var, and then we have 2. And then we can copy over these trees as well. We have the store and the load. I'm gonna assume that we've like alloced it somewhere else. We're just gonna put it on another layer so it'll be less awful to work with in a second. So we have the store. And that also gets its own layer. Let's pen this in again. This is very scuffed. We want to keep the load there. And, oh, this is I'm regretting my ovals now. Okay. So now the first thing we have is the load. So we have var equals load putter 1. This is also putter 1 actually. Whoops. Can we just color over this and then rewrite it? Yeah, let's do this sketchily. That's in the spirit of the stream. Let's write the little serifs by hand. There we go. Yeah, so we have var equals load putter 1, var equals var plus 2, and then we have store, and then what order did I do this one? Var and then putter. So we want store var. Oh, I'm on the wrong layer. Did I put this on the correct layer? Uh-oh. Okay, we're just gonna go with it. We're just gonna roll with it. Yeah, so we want to store var into putter 1. Yeah, so this is very scuffedly drawn, but these are like the 3 trees we have, right? And then what we can do with this now is we can start merging them in a way. So we can take, I guess we can like work forward to back here. So we just go left to right. So then the top one here is var. We can merge this into the var down here. It's not as simple as this for reasons that I'll go over next time, but let's just make a new layer. Let's just plop it right on top here. And then just so this is a little bit prettier, let's like, let's make this, there we go. Now we have an edge there. So let's merge it down again, and then let's like, yeah, okay. So we have like 1 tree merged in here now. So now we can take this tree, let's like, we're going to make a mess. This is inevitable. So now we look at this. We have a var here, we have a var here. We can merge these into each other. And there's like a bunch of other rules for like how to merge things, but yeah. Let's get at it. Good to see you. I'm giving tree merging my best possible explanation here. It is very scuffed if it wasn't obvious. Yeah, so let's like throw that right there, you know. Let's erase this as well, and then we're gonna color over this a little bit more. Yeah, okay. So now let's fill in these. And we merge these down, and then let's move this up. And let's make it a little bit bigger so we can read it a little bit better. So yeah, we've taken all of this, we've merged it into one giant tree, and that's like the step 2 that I've listed in this pseudocode. So we've generated trees, which is what the 3 original trees came from, and now we have merged the trees. And there's like a bunch of other rules for like which trees are mergeable, which aren't. But the idea is then we have like a bunch of these that we can then, I guess, turn into instructions. And then from here we can cover the tree with different quote-unquote tiles with different costs that we can hopefully minimize in some way. And those will be what corresponds to our actual instructions. Yeah, so I'm not really sure how to like describe, or like the tiling here is gonna look a little bit silly because it's just gonna be the same thing in reverse here, but there's definitely like, there's definitely a way we can, I guess, make it more efficient. Yeah, so like an example where like it would be different is like if this was like a different variable here, and that would get a different tile because we have different instructions for that, I think. I might be wrong, but yeah, that's like kind of the general idea of how we want to do tree tiling. But to get to this point, we need to generate the trees, all the small trees, each of the individual trees that we ended up merging into this one. An example of like a tile that could be more complex and doesn't map one-to-one is like var, we have like var equals plus yeah, let's do like plus, and then this has like 4, and then we have like times, we have like, or actually no, we have, what is the LEA instruction again actually? LEA x86 64 LEA. Yeah, this load effective address thing, the compiler really likes it to just do a lot of math because it's quite fast, if at all possible. Could be covered by separate load add to store or by add var2. Yeah, that makes sense, yeah. I guess this whole thing does, you can kind of like tile it in one big tile, which is kind of funny. I haven't like thought about what the tiles will look like beyond just like the simple ones and then like the somewhat obvious small ones. So like LEA is like the big example here. So we have like plus, we have like A, and then this gets like times, and then like B, and then like 4. And then this, instead of having like this instruction and then like this instruction, also I think I'm missing a register somewhere here. Yeah, I'm definitely missing a register somewhere. It's like R, I don't know, like some, anyway, yeah. But then this can be replaced with like LEA of AB4. I think that's the order. Yeah. Yeah, that's like an example of a non-trivial tiling. And by the end of this, we should have a set of instructions that is somewhat usable, hopefully, maybe. Yeah, we'll see what happens. Okay. So then, where am I in this? Can I, is this the thing? This is the thing. Oh, that doesn't help me though. Okay. I was in the middle one. Okay, I see. So let's go back to everything that we want again. And then, okay, let's generate more tiles, I guess. We have these tilings. Hopefully, surely the return is not that bad, right? I would be upset if the return caused a lot of problems here. Let's make a ret node. The node. We can kind of just copy all of this stuff, right? And just delete from it. Let's make this just a T. This constructor, I don't think, yeah, we don't need, I don't think we need an explicit Oh. We don't need an explicit constructor for this, right? Or maybe we do. How does virtual work? Do sub classes need explicit constructor? Uh-oh. Gulp. Okay, let's look at these. Let's look at this. Maybe this will tell me everything I need to know. What? Okay. Super as a default. That's not what we want. Okay, so I think we need another constructor, right? This is awful. I think this needs a constructor. Right? Any C++? Any C++ heads in the chat that can... What is happening here? Yeah. Anyone know if I need a constructor for this? Or do I need to like default it explicitly? I feel like that's what I want to do. Let's give it to ChatGPT. I think we're also going to need visitors for these eventually. Oh, that is not what I wanted to give it. Let's give it this. Let's give it node, which is a little bit silly. Okay, it doesn't. Okay. Oh, no, JS? Unlucky. All good. Interesting. So we don't want to do that. I see, okay. So it doesn't need it. Does the node class need anything? Yeah, okay, so we don't need anything here, I think. I don't think I need to default anything then. Okay, well, we'll find out the hard way if this doesn't work, I guess. Yeah, so let's delete that. We can kind of just do this, right? I really hope we can. That would be very nice if I could. Where am I implementing all this? It appears I'm not implementing any of this anywhere. I would need to implement this still. Let's do that later. Let's implement all of this later once we start hating ourselves for it. Let's visit. Actually, I should just steal this line. This should be return or terminator return. Oh wow, I can't type. It's T. Okay. So then we can kind of just like do this sort of thing, I think. Instead of op, we want source, I guess. We can get rid of those. We can replace this with solve value of t get value. And we want ret to be return or ret node. Ugh. Let's make this not just ret. Okay, so I'm gonna do that. I wanna set source to std move source, and then you can push that back, I think. Let's see if this builds. Glop. Okay, well, that was expected. Okay, that's implementing that. Yeah, so this is done. This is done. Let's use a different green. Yeah, there we go. Okay, next is load. So we want to get load, store, and allocate. Maybe I do allocate first because I guess that's like a more reasonable build up to it. Just to like generate pointers, I guess. Instruction, allocate. This is instruction. Let's make this a load and make this a store. Maybe I should put these in order. Let's put these in order. So if allocate, load, store. Yeah, okay. What the hell? We'll just template all these out. First time here, working on the compiler myself. Only done the Lexer so far. Yeah, I think that's a pretty good start at least. I've never really understood the Lexer that well, so it's like it makes sense, but like I've always just like rolled it into the parser, so I think I've only explicitly written one Lexer before. I'm dealing with the backend now. I have a front end, I have some semblance of a middle end. The biggest hole I have is the backend right now, so I'm currently working on instruction selection in the backend. This is a branch. This is cond branch. Yeah, we can just slap all of these in here, I think. Call, I guess? Oh, we have store, and then we also want fee. Okay. So we have 1, 2, 3, 4, 5, 6, 7, and then 2 more down there. So that's 9 total. That's good. Yeah, okay. So then how would we want to generate these? I guess we could figure out what a context will be. So each f in mr get functions. Oh, here I think we should add calling convention stuff. Or no. We want f get basic blocks. Or maybe we should, no, this doesn't make sense. We need a generate linear. So we want to generate linear IR. We want to traverse that to like make the trees. I think the Lexus tokens are grouped into meaningful abstractions. Yeah, I mean that makes sense. It's just like, it's kind of just, I guess like it makes sense to think of it as like defining what a quote unquote word is, and then like we give the words meaning later. It's always just like felt very intertwined with the parser anyway, so it's just like kind of awkward for me at least. There's front end for compilers. Well, the front end is in like relative to the optimizer, I guess. I guess it's been a while since I've given the little spiel, so I guess I could do it again. So let's say we have like N source languages, so we have like C, we have like C++, and we have like Rust as an example. And then we have like M different backends. So we have N front ends, we have M backends. And so we want to generate, or let's add like Swift as well. Just for fun. We have M backends, so we have like x86, we have x86, 64, and then we have like some sort of ARM here as an example. Yeah, so if we were to write an individual compiler for each of these combinations, we would have to write n times n compilers, because each of these 4 front ends, or each of these 4 source languages would require 3 compilers. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a lot of duplicative work, and as this scales, this is very awful. So the idea is we can use a centralized optimizer language. LLVM has LLVM IR. What I have in my compiler is what this MIR thing is. It's like opt language. And the idea is then we can like implement a single set of like optimizations that we can just reuse across everything. So we can do like optimizations, and then instead of having to write n times m compilers, we can write n different half compilers from the source language down to the optimizer language, and then we can write m different more half compilers from the optimizer language down to the assembly. So if we were to like divide the tasks up here, this grouping of lines is considered the front end, because that's like, this all handles like language specific features. This is considered the middle end. Let's use a different color. Let's do like red. Because this is like the core of the compiler that like we can reuse across literally everything. And then the final little section down here, the stuff that turns it into assembly, this is the quote unquote backend. And yeah, that's like kind of the short explanation of how most modern compiler architecture is designed. Is this industry standard? I think so, yes. LLVM does this. I think GCC uses like a similar division. Even if it's like a very specialized compiler for like one task, you still want to like at least think about it or like architect it in this way, because that also like, it's also just like helpful for software maintenance, because then you can kind of like divide tasks between different parts of the program a little bit more paradigmatically, I guess. Yeah, but that's like the short spiel. It's been like 20 episodes since I've given it, 20, 30 maybe, so don't worry about asking, I guess. Yeah, so we want like, yeah, that's like, that is what the front end is of a compiler, I guess. The little green section. Okay. So we need something to linearize IR as well. I'm a little bit scared to write that, because that might make a mess. I have some ideas on how to do it. I don't want to worry about it right now. For now, I just want to write a couple more nodes. So I want to get allocate, load, and store done. Slightly different from what I thought was the front end. Yeah, I mean, there's a lot of, I guess like a lot of different fields define like front end, middle, and back end differently. It's not really standard, so like it kind of makes a mess. Like if you ask a hardware person what a front end is, they will give you a different answer from me or from all the web dev people. Actually, I happen to know a guy. Let me see if he's streaming. Okay, he's not streaming, but let me pull up his channel real quick. This is not him. Subscriptions? This is on my second monitor. How do I pull up his... Oh, I have to scroll. Okay. Alright, give me a second. Yeah, I guess I should also plug my friend while I'm at it. Yeah, so this guy, he's quite cracked. If you haven't checked out his content, you should. He is building a keyboard right now, so it is. he is very cracked. You should like sub to him, watch his stuff. Ask him what a front end and a back end in hardware is, and he will give another different answer. So yeah. Forgot how to the Apple II I interviewed for and forgot how to do C++. Finally got back. Curious, I got positive feedback. That's crazy work. I guess like if you, as long as your like thought process was fine, right? I think that's what they look for. So did you get an offer or how'd that go? Okay. Lexical analyzer into parser, semantic analyzer, and then identifiers, and then IR, and then ops. Yeah, that's kind of like a pretty good representation of what I have up to this point. There's also like there's some like other desugaring stuff that happens. So like things like turning the loops that we know and love into just like jump instructions. Or like getting rid of like function scopes or like variable scopes. Those are like other things that it handles, which a lot of us take for granted, to be honest. And it's just really cool. Where am I? Let me find my diagram for the backend at least. I put it in my Discord, which if you have not joined, you should definitely join because we get to chat with a bunch of cool people. Okay, so this is like my plan for the backend. The green is like the stuff I'm trying to implement right now. The blue is like kind of the list of tasks that we need. So can I just open this real quick instead of having this up? Then I can annotate over it. Paste? Okay, perfect. So let's try this again. Yeah, so usually the optimizer IR is like, and when I say IR, I mean intermediate representation. Think of it as like sub-language, I guess. So the optimizer IR, this is like the middle end, I guess, this red box. So the middle end is usually like a control flow graph because that allows us to like analyze the program easier. But eventually you have to turn it into assembly, which is, well, a flat straight line program that maybe has some jumps here and there. So we need to linearize it in some way. And so we need to do that. We also need to like turn the arrays that we have into like actual memory operations with like offsets and stuff. So that's like 2 tasks. I have them scheduled up at the front here. I'll figure out how to do that eventually. And then the rest of these tasks, there's like 1, 2, 3, 4, and then 5 tasks, I guess. So the first one, which I'm working on right now, is instruction selection, because the assembly does not map one-to-one with the optimizer language usually. So you want to have some sort of a process to lower them, or at least like convert them, because it's not one-to-one. if you were to just like expand this the optimizer language like macros, that makes really slow and really inefficient code. So ideally you'd like to have some other algorithm to do it. The way I'm doing it is I'm sort of generating trees out of it, and then covering it with tiles that represent different instructions. That is like the very, very high level explanation. It'll make more sense across the next couple of days. From there, there's a couple of other tasks. The biggest one is register allocation, because at this point, we still have a bunch of variables, and as we all know, we don't have infinite variables on a CPU. We have a certain number of physical registers. So we need to figure out a way to turn the possibly infinite number of variables we have into a physical, into like 16 different registers, maybe, for example. The way I think the literature really likes to do it is just is treating this like a graph coloring problem, and that's what I'll do. I think LLVM doesn't do that, which is really funny. I think they just do like I forgot what it's called, but they just like traverse through it and call it a day, pretty much. Another task we need to worry about is scheduling, because we want our code to be pipelinable by the CPU. So that might mean like reordering some instructions to support that. And then this term people optimization, this refers to like small micro optimizations that will make the code quality a little bit better. So like if we have like a store into like putter followed by a load immediately from it, we can just eliminate the second load pretty much, and that will hopefully speed things up a little bit. So that's like 4 of the main proper backend tasks. The last one is just like generating actual assembly, which I think is pretty self-explanatory as to why that's important. But yeah, that is like the very TLDR explanation of what the backend does. Yeah, I remember this. I remember hearing about this interview stuff. It's unlucky, but you got the offer, right? right? Gulp. But yeah, I mean, object-oriented programming is a mess anyway. I don't particularly like it. Which is really funny, because I am proceeding to do exactly that here. We have singleton at home in instruction, I think. Instruction? Operand. Yeah, we have singleton at home. Yeah, there's a lot of different, so many design patterns. So many of them are so contrived. Waiting for approvals, but very likely. That's crazy. Well, I mean, congrats, I guess. That sounds pretty good. You should be fine then, surely. I've been told Apple usually takes a really long time, so I guess that is how it is. Yeah, you can definitely spend a lifetime studying C++ and still not know everything. It's so fun. Fun, cool, open to interpretation, but I think it's very cool at least. Okay, let's implement LK. How did I decide the tree should look? Putter, allocate, and v. So we need a load node, a store node, and an allocate node, I guess. Yeah, so we can just copy this, to be honest. Allocate node, allocate. Yeah, this will be like a stack frame move, I think. And then we can like merge those later as well. That will be nice. We can find a way to people that, I guess. That will be how I handle that. Yeah, so we have allocate. We have a source. Yeah, that should be fine. And then we also want to do the same thing for load. This is very boilerplate. Looking at Fang, quant, low level embed stuff. Yeah, I think that's a pretty good pal to look at. That's kind of what I've been looking at as well. Are you consistently applying? Yeah, I've been trying to, but it's low-key burning me out. So I've been kind of chilling for a little bit. Yeah, that's kind of just like reality, unfortunately. Let's see, store, load. Yeah, we should reorder some of these as well. I think return will get pushed promptly to the bottom here. Yeah, I think that's all of what we need here. There are so few roles. Yeah, it's rough. Nvidia has one. You can also like kind of. You also have to like really be contrived. You have to like make. I guess you have to like contrive yourself into spaces. Like, I think if you like apply to quant broadly with like a compiler resume, they'll probably find something compiler-y for you. That's where I've been like mostly setting my sights, to be honest. I feel like it's the most realistic in terms of getting to do what I want to do. What else am I missing here? Oh, right. Store has two things. So we have source and then we have putter, I guess. Maybe this should be a size, I guess. Yeah. We have source and then we want and then putter. Where am I? Putter. Yeah, I feel like internships is like definitely more doomed for like compiler stuff at least. But also like there's definitely ways to break in at least. Why would you like a compiler role? I just very, very much like compilers. I've been doing like, I guess like, I took a compilers class and I thought it was really cool. So then I did compilers research for a year and I'm still doing it. It's gonna be what my master's thesis is about, but I just think they're really cool and I think I would want to work on them for the future at least. Load, I think we don't need a putter. Yeah, we don't, or no, we don't need a source. We do need one here though. Yes, you can do that. So allocate just this size. Load has that. Putter, store has a putter and a source. Yeah, this looks good to me. So few companies hiring? Yeah, I mean, it's definitely tough, but if I'm cracked enough, I think I'll make it. How long have you been coding? How long did you switch to NeoVim? I've been coding for like, I guess 4 years if you were to like accumulate everything into like actual coding time. Yeah, and then I switched to NeoVim start of last summer, so I guess it's been like a year and a third, so it's, I guess it's, make of that what you will. It took me like 6 months to like truly become comfortable with like the motions, so yeah, it's been a bit of a journey, but now I feel fluid enough to the point where I would rather inconvenience myself in every aspect of life every aspect of life that has keyboard motions rather than not using the motions, which is pretty funny. Yeah, I guess like I do have less competition. At the end of the day, I think like just if I'm qualified, that is the big thing. I know of a couple people out of my research lab that have gone straight to compiler jobs, so there's definitely hope for me. I just need to like be cracked is the big thing. And I'm getting a master's, so hopefully that at least gets my name on the piece of paper. I also think like, I don't know, it's at the end of the day, like if I'm cracked enough, I will get a job. And I just need to get to the point where I'm cracked enough. Really good undergrad GPA? It's all right. I think it's a 3.8, but it rounds up. So it's like, I guess, all right, I guess. But I'm pursuing a master's, so I guess it'll matter significantly less. I don't know, maybe I'm just like used to like thinking about GPA in terms of like law school and med school, where like everyone wants a 4.0 and it's like miserable. I mean like, it's CS, so like I think I at least understand an inherent degree of like GPA inflation. Or at least that's why I like undervalue it at least. Okay, so we have a putter. So let's start with the value for the size. So what is the size? Alloc type. Let's just add a to-do here, because we don't really have a way to do that yet. Size equals oh boy. How do we do this? Make unique. This will be a what do we give this? This is a, what did I call it above? Immediate. So this gets, how big is this again? 8? 64? What's that? What unit is this? An alloc. What does an alloc turn into? How long do you spend on average day? It's mostly just like the stream duration. Historically I've averaged like 2 hours a day. So that's like what, 14 hours a week? The past 2 weeks I've like slowed down a little bit just because it was like midterms week. And I need to worry about that, but yeah. Okay, so we want 8, looks like is the number. Or at least that's the scale. No, we want 4, right? Alright, no. We want 8. For a proper stack frame size. Okay, so we have that. This sucks a lot. Okay, so we have size, and then next thing is the alloc. Auto alloc is stood make unique allocate node. That takes nothing. So then allocate set size to size. Just did move size. More time watching people look and then doing stuff myself. I feel that, yeah. It kind of happens sometimes. But nothing precludes you from like doing work at the same time as well. Okay, so then we want the putter. What is the putter? Where are we storing this? I guess a register? Or actually, no, wait, no, this would... How do we even do this? Let's look at the add example. Oh, we have to worry about like addressing modes. Okay. Okay, well. Huh. Okay. We wanna... Is there a thing we could do to like coalesce all of the allocates maybe? I'm like really struggling here. We might have to go back to the drawing board on the memory stuff. For now, we're just gonna stick it in a register, I guess. Better to have something and have it be wrong than to not have anything, I guess. Okay, so we can just like steal this code maybe. Yeah, but instead of this, we can... yeah, we can change this to allocate. Yeah, this looks reasonable enough, I think. Yeah, and then we can cover this with tiles, I think. I hope. Am I doing this right? I hope I'm doing this correctly. We can do the load here as well. So load, this is stood, make, unique, or we want to stood, make, unique. This is a load node. That's fun to say. Yeah, try saying load node a couple of times. That's pretty fun. And then we have, what do we call it here? Putter. Where does this come from? Should be a resolve value. It's I get putter, I guess. Okay, so we want that. Yeah, and then we can get the number there. So then this corresponds to the same number, I think, so that should be fine. This is now putter. Do you have any tests? Yeah, but they're all written for the front end and the middle end. It's all just a bunch of regression tests, pretty much. None of that will be helpful for what I'm currently doing, but there will be a point where it will end up being useful. This should be a store now. Store node. This should be get Or wait, no, we should. Oh wait, this load should also have load set putter to putter. And this should be load. This should be, yeah, okay. That looks correctly chained now. Allocate takes size, and then allocate, and then reg takes allocate. Okay. Okay, so we want putter, and then we want source get value. So in store node, we want to set source and set putter. This is the order we have. It's not reg anymore, it's store. Okay, I think that's everything that we structured it as for now. I'm gonna need to figure out a better way to, I guess, represent these, or like figure out what to do with this. I guess we just stick it in register. That would make the most sense. Or no, it wouldn't. We'd have to do something else with it. I guess it's a pointer, so that would, I guess that makes sense in the context of this. Yeah, I don't want to deal with the fee right now. Everything else requires writing more nodes. It's just really annoying. So I think I'm just gonna call it good here for now. Gmake. Oops. Emma cake. Let's just rebuild everything. I'm also going to make the test because nothing should break. Yeah, okay. 34 passed, nothing failed. The make file target skips all empty lines and all lines that say skipped. We skip the ones that we don't have test expecteds written for. So that's why it's only 34 and not 40. So yeah, I think that's a pretty good state. Let's commit this. Okay. I think this is a pretty good place for me to call today's stream. It's been 2 hours. I need to eat something. I'm still hungry. I have leftover Chipotle. That is looking very appealing to me. Thank you all so much for showing up to my stream, especially if you've been here for the entire 2 hours. It's a lot of time out of your day, and I respect it a lot. Make sure to sub to the channel if you haven't, and like the stream. It helps out a lot with the algorithm and helps get my content out to more people. And while you're at it, make sure you join the Discord. The link is also down there. You get to chat with the broader community and also, I guess, watch me paste really dumb diagrams and me not remembering what I was talking about in the past. So that's all fun. And yeah, make sure you add me on LinkedIn and GitHub to stay up to date with what I'm doing as well. Yeah, take care, y'all. Take it easy and have a wonderful rest of your day wherever you are.